Okay, today's lesson is we're solving systems of equations using multiplication with addition or subtraction. This is anytime you have not the x or y's same or opposites, or we don't have the y equals or x equals equation. So if we have something that's not like any of the three ways that we did yesterday, we have to have a fourth method to find what the solution is. So the first example we're going to look at is 8x plus 2y equals 4 and negative 2x plus 3y equals 13. So with this method, what you're going to do is you're going to either get the x numbers to be opposites or the y numbers to be opposites. Now that could mean that you have to multiply one or both equations by something in order to do it. An example on this problem is because the 2 and 8 both go into 8, that I could just multiply the bottom equation, including the number on the right side, by 4. And if I do that, and not change anything on the top, I will end up getting opposites for the x. Now I'm going to show you a different method when we do the second example so that you can do it no matter what the problem is. But in this case, just by multiplying the bottom equation by 4, we are able to get the x numbers to be opposites. They're both going to be 8. One's positive, one's negative. So the top equation I don't change, I just copy it over because there's nothing to multiply by. The bottom equation, I'm going to distribute the 4 to everything. So 4 times negative 2 is negative 8. 4 times positive 3 is 12y. And 4 times 13 is 52. And then at this point, now we can add down just like we did yesterday when we were solving. The x's are going to go away, so I'm left with 14y equals, and I add down here, I get 56, and now the solving is no different than what we did yesterday. So steps for doing this is you're going to multiply one or both equations by a number. To get either the x's or y's, opposites. After you do that, you're going to add down as long as we come up with opposites and solve for whatever the variable remains. So in this case, we're going to divide by 14. We get y equals 4, because 56 divided by 14 is 4. And just like yesterday, you're going to take this answer and plug it back into any of the equations. So plug the answer you found. So it doesn't matter if it's the top equation, the bottom, it doesn't even matter if it's a changed equation. We can use any of them and it will come out okay. I'm going to use the top given equation, so I'm not going to do anything with the 8x because we found y. I have to fill that in for the y here. So I have plus 2 times 4 equals 4. And now I multiply the numbers here. 8x plus 8 equals 4. I get rid of the addition or subtraction, so I subtract 8. I get 8x equals negative 4 and divide by 8. And we reduce the fraction if we can. You certainly could change it into a decimal as long as you don't have to round. And when we do that, x equals negative 1/2. And then our last step, just like yesterday was, we need to write the ordered pair. And so don't forget to write your answers as ordered pair is x comma y, so my x number was -1/2, y is 4. So hopefully this helps with coming up with the answer as we go through this. Now, we're going to look at our second example. And I'm going to give you a different method for coming up with the solution, or a different way of coming up with the numbers. So there's a little bit more process to this. So we have 3x minus 6y equals 9 as the first equation, negative 4x plus 7y equals negative 16 as our second equation. Now, another way that you can do this is you can just take the front numbers and swap them. Now, the one thing you want to be aware of is that I want to have one negative sign. So because I already have one of the two numbers being negative, I don't need any negative signs on the switching numbers, so I don't want to actually put a negative on the 4. I'm just going to move the 4 up, and then I move the 3 down. If these were both positive or both negative, then I have to switch one of them. And it doesn't matter which one I switch, but because we were given opposite signs on the number, then I don't need to do that. And then on the top equation, I have to multiply everything by 4. So I'm going to end up with 12x minus 24y equals 36. I multiply everything on the bottom by 3. I get negative 12x plus 21y equals negative 48 when I multiply 3 times negative 16. And then at this point I add down. The x's are always going to go away when you use this method. If I chose the other method, I could pick either x or y to change or multiply. With this method, you'll always get rid of the x. I'm left with negative 3y. And when I do 36 minus 48 or plus negative 48, I get negative 12. And I divide both sides by negative 3. I get y equals 4. And just like the last example, after we get our first answer, we plug it back in. I'm going to use the top equation, so I have 3x before I changed it, minus 6 times 4, because we came up with 4. I'm filling in the 4 for y, equals 9. And now I solve. I always multiply, so I have 3x minus 24 equals 9. I add 24 to both sides. I get 3x equals 33. And we divide by 3 to finish solving for x. X equals 11. And again, don't forget to write your ordered pair. It's x comma y. And we get 11 comma 4. So hopefully this helps with coming up with the answers. Now, the other thing that we need to look at today is we have special solutions. So in order to do the special solutions, I'm going to go through a couple more examples. Now, special solutions are either you have no solutions or many solutions. And the special solutions happen when both variables go away in the solving process. In other words, when I'm solving and I do this adding down, if this were a no solution or mini solution, what would happen is I would have had a positive 24 here. So when I add down, the x's go away because they cancel each other out. The y's then would also cancel each other out. And by having that happen for both, what happens then for our answer is we get one of the special solutions. So if they both go away, you can either have a no solution. Now, no solution is when both variables go away and the answers left are not the same. In other words, you might end up with something like 3 equals 5, where the two numbers on the two sides, or 0 equals 5, where the two numbers aren't going to be the same thing. a mini solution, and both of these you have to write the words down at the end. What happens here is the answers left are equal. So they could be 3 equals 3, it could be 0 equals 0. But you're going to end up with something where the two variables are going to go away and the numbers left are going to be the same numbers on both sides. So an example of one of these would be if I had 2x minus 3y equals 4 and 6x minus 9y equals 8. So these are our two equations that we're going to use to do this. So the next thing we're going to do is the same as what we did on the second example, and that's we're going to go through and come up with the numbers that we have to switch. Now in this case, notice they're both positive. So when I switch them, I have to make one of them negative. So I move the 2 down. I'm going to make the 2 the negative, and I'm going to move the 6 up to the top because, again, we're just using this to help get rid of the variables in front of the x's because the numbers in front will become opposite. So now I distribute the 6 through the top equation. I get 12x minus 18y equals 24. I do the same on the bottom. I have negative 12x. I get positive 18y equals negative 16. And so when I add down, the x's go away, the y's go away, so we're just left with 0 on the left side. And on the right side, I add down, and I get 8. Now, because these two numbers are not the same, that's the case where it's a no solution. So you write the words no solutions once you get to this point. There is not an ordered pair that you write down for this. You're just going to write the words no solutions, and that's your final answer. If it's a mini solution, these would have been the same. It could have been 0 equals 0. It could have been 5 equals 5, but they have to be the same number. So hopefully this helps as you do the assignment tomorrow.